Welcome back, ladies and gentlemen. Today we're going to start talking about a concept at its very basic level that's actually really important in algebra, and that's pre-algebra, algebra one, algebra two. And as a matter of fact, it's actually the basis of calculus, which is engineering and medical fields and chemical fields. All of those fields deal with calculus. So it's very important that we start on this, and all of calculus is based on the idea of slope and then how to interpret it, find it, interpret it, understand it, things like that. So today we begin a very long journey that's going to take years to go through, and some of you will just end at just understanding and be able to apply it. Others will go on able to how to build things with it and different things like that. So finding slopes at its basic level is asking how far do I go up as I go over. It's the idea of movement, right? Through whatever you're doing. If you're going up a staircase, it's how high of a step are you taking as you take a step forward as well. If you're walking in the hallway, it's asking how far up are you going compared to over. Really, there's no change there. It's a zero. So if you're walking, your slope is zero. If you're walking up a staircase or down a staircase, your slope is determined by different things. And that's what we're talking about today. There's a fourth option, but we're not going to bring that up quite yet. What we're really looking for is over here, I've defined it. Slope is how far do I go up as I move forward. Now, there's a couple of things that are misleading by this wording. Up really is positive or negative. I can move negative up. Basically, it's another way of saying down. But mathematically, there is no difference between up and down. Okay? Really philosophical statement here. Direction is based on where you are, and we'll talk about that in class. Now, also, forward, if up is either positive or negative, the word forward is either positive or negative. So we have to remember that we're talking about up or down, left or right, when we use the words in this context for up and forward. Now, with that, we have some math notations you're going to need to get used to eventually. So slope has an equation or idea behind it, and that is it's the change in my height, how far I go up, as I move forward, over divided by change in width. This is slope. Change in height, change in width, and it's a fraction. So we've been talking about ratios. We're still talking about it. In particular, we're going to be talking about to a graph. So if we imagine this is a step, what we want to know is if we have a stair here, right, just like you're coming upstairs to go to class, what we're asking is when you have your foot down here and you go up and step here, what was the slope that allowed it? If you want to think of it in terms like this, there's a legal slope and an illegal slope. In other words, if your stairs are too steep, and that would be one word we use when we talk about slope, then it's actually illegal to have those stairs. If the tread's too small, there's different things like that. So this really goes in, slope, there we go. This really goes into a lot of life that could be going on, a lot of builders. It goes into how we construct really anything. We got to be able to use this idea. So it's asking, how do we do this? Well, we don't look at the step, and the easiest way to do it is just pick 2 points. And we have one here, and that's 3, 4, and we have one here, it's 0, 0. What it's asking is how many units did we go up? Well, we just count from line to line, right? And if I do that, I find that I go up 1, 2, 3, 4 times. So I go up, indicated by plus, 4 times. All right, now that I know how far I go up, I need to know how far I go over. Well, 1, 2, 3. I go to the right, so it's a positive. Remember, numbers to the right are positive, 3 times. What I'm going to be able to do with those two numbers is use this idea of slope. So my slope is, or is equal to, a fraction where I went up 4 times and I went over to the right 3 times. Remember, this plus is right, and if it was negative, it would be left. And then that positive on the 4, oops, using the wrong pen here, here we go. This means up, and if it were negative, it would mean down. So we have a positive 3 over a positive 4, and if we look back to our factor fox, I have a positive and a positive, which isn't on there, but if we have the same sign, it's positive. So that means my slope is the same thing as, because I don't want to write my signs, I just want my numbers, 3 or 4 over 3, and this would be my answer. My slope is 4/3 for this graph because I went up 4 units, that's my numerator, then I went over 3 units, and it was up, so it's positive, and it's right, so it's positive as well. Now here, we can do the same thing. We're going to pick 2 points. Luckily, again, it's already given to us for 2 points. I have negative 2 and negative 2, and 4 and 1. Now, what I'm able to do is ask, how far do I go up from my lowest point? 1, 2, 3 times. I have to go up 3 times. And then, sorry, I'm going to go ahead and start writing it. So I'll do my slope equals, I did that again, positive 3. I wrote slopping. I'm being sloppy. See what I did there? I know, dad humor. All right, then I'm going to go, then I have to go figure out how many units do I go over from one point to the other. So 1, 2, 3, 4, 5, 6. So I went right 6 times. Now I need to write my final answer, which means I need to get rid of my like sign. So I'm going to look at my factor fox again, and I'm going to remember that if I have the same sign, then I'm left with a positive. So that means I don't need those positive signs, I just need the 3 over 6, and I'm going to recognize something at this point. I can simplify that, because if I divide this 3 by 3 and the 6 by the same 3, I get 3 divided by 3 is 1. 6 divided by 3 is going to be 2. So my slope is actually going to be 1/2. Now here's the nice thing that tells us. I don't have to go up 3, then over 6 to reach another point on this graph. What this tells me is I can go up 1 unit, and then I can go over 2 units, and I'll be at another point on that same graph. Again, I can go up another 1 unit here and go over 2, and I'm at another point on this graph. And if I go up 1, then over 2, I can read. Every time I go up 1, I can go over 2, and I will always be on a point on this graph here. So slope tells us how to go from one point to another on a graph so that I can imagine how far or how long it'll take me to get from one point to another just knowing the slope rather than where the 2 points are. Same thing happens over here. If I wanted to go to another point on this one, I would go up 1, 2, 3, 4 times. I would go over, now it's off the graph, but I go over 1, 2, 3, and if I took a straight edge and I extended this graph out, what we would find is, if I could draw it correctly, I'd be on another point on this same graphed line. So a quick review as quickly as we can. Slope is how far do I go up as I move forward. So think about it like we were walking upstairs. Okay, In math, that means I have to find the difference or distance or change in how far I go up and compare that to, and we do that through division, compare how far we went up to how far we went over. This is how we notate it. Triangle Y means change in height. Triangle X means change in width. Now we do that by just finding points on our graph. Here they're given to us. I go from one point to the other. So how far did I go up? I went 1, 2, 3, 4 units up, 1, 2, 3 over. I wrote that here. I simplified my answer so there's no more signs and got my answer, and did the same over here. Even had to simplify my fraction to get my answer of 1/2. If you have any questions, make sure you email me, get those into me as soon as possible so I can look them over, get them addressed. And stay safe, guys. Enjoy the rest of your evening.